Greetings. In this one we can talk about ring theory a bit, about rings. So a ring is this set R, in general called R, with addition and multiplication, and it has some properties in the definition. You can look that up. We've also covered it before, and this time we're going to be talking about what is an integral domain. So some rings are called integral domains. They're specific rings that are both commutative. That means in multiplication AB equals BA. And also they have an identity and in multiplication, and we also have a thing that when two non-zero elements are multiplied, they give a non-zero element as a result. So you cannot get the zero element from multiplying non-zero elements of that ring if it's an integral domain. So if for any two AB that are not equal to 0 and are in the ring, AB doesn't equal 0, and that ring, by the way, we were talking about the ring is commutative, so R is and R is commutative, so we can write it maybe R commutative, then it's called an integral domain. Integral domain. And this is interesting. We can have some examples. Many popular sets are integral domains, it turns out. All right, so we can have rings where you can have non-zero so-called divisors. That means we can multiply some non-zero numbers and it gives a 0 as a result, but not in integral domains. So integral domains do not allow this. Also, by the way, as we've stated, R is commutative. If it's an integral domain, if it doesn't have the non-zero divisors, and it's also a commutative ring, then it's an integral domain. And so we can now look at some examples. So let's clear this. And as examples, we can give, for example, Z as a ring, because for any AB that are not 0, or let's say for any AB in Z except 0, we have that AB is not equal to 0. That applies to Z. And also it applies, another example is, so that's one example. Another example is rational numbers. And you can see that also because if you have a rational number, it's expressible as a fraction, and if you take two non-zero fractions, it gives again a non-zero fraction if these two are multiplied. So it also satisfies. The same goes for real numbers. So these are some examples also. So in short, an integral domain is a commutative ring with no non-zero divisors, meaning that if you take two elements, they are non-zero from that ring, and the multiplication then is non-zero as well, then it's called an integral domain.